Hey everybody, this is Ben back with part 1C of homework 2. Shout out to Sidecam, everyone watching on Sidecam. Love you guys. Anyway, I need to demonstrate numerically that for a given average and standard deviation, that maximizing the entropy of a discretized probability distribution will yield the normal distribution. Well, there's a few parts to that. I need to demonstrate it numerically, which means I'm going to be busting out Python. I need to give it an average and a standard deviation. So those are two functions that I can sort of make up, and those are two things I'll have to explain through. And then I need to maximize the entropy of a discretized probability distribution. And so this probability distribution is what I did in part B. So I'm just going to be taking that and putting that into Python while making a few small changes. I'm going to show that when I give it these constraints, an average and a standard deviation constraint, then the distribution is going to add up to be a normal distribution. So that's sort of what I'm going to work through here. So let's go back to Paint. This is the file I had last time with just a little bit of small change. Well, actually nothing changed, same thing as before. And let me copy over this function for the entropy, right? So what I want to do is I want to maximize this function that I derived last time. But if you look right here, I have SciPy optimize minimize already up on my browser. And that's because this is the function I'm going to be using. Now, an important thing to keep in mind about SciPy is that it just has this minimize function. It doesn't have a maximize function. But of course, this isn't too bad for us because the opposite of minimizing is maximizing. So if I want to maximize this function, then I'll just multiply it by -1 or get rid of this negative sign. And then I can just minimize this function. Now, I'm going to be minimizing the function in terms of the probability of I, and I'm not going to mess with this n, which is the total number of data points, or in this case, students, for this example we've been using. So I can go ahead and also erase this n. And then I'm left with this function that I'm actually going to be maximizing. So that's pretty sweet. Let me go back to Collaboratory. And this is what I'm going to end up doing. This is the chart I'm going to end up getting. But let me delete all these cells and start fresh. So up here, I imported from SciPy Optimize, import minimize. That's a quick change that I made from the last time that I don't want to have to retype out. So then let me go ahead and define the function that I talked about earlier. So the function, I'll just define it as maybe negative entropy, and I will define that in terms of the probability. And that will just return the sum, so numpy summation, which numpy summation just sums all the values of, what am I looking at here? P times the natural log, which would just be np log. By default, np log is going to give you the log base n, so or log base e, or the natural log. So times that of p. So there is my function for the negative entropy. Now I want to minimize this. So if I can type, which I can't right now. Come on, let me type. Okay, sweet. So I want to minimize this. What is the documentation for minimize? Let me take a look at this. So I need to give it a function. I need to give it some initial conditions. I can give it some arguments, but I won't. I can give it a method, but I'll just go with the default. And yeah, the chosen one will be one of these three. I think it'll choose SLSQP, but I'm not certain. Depending on if it has constraints or bounds, which I will actually be giving it constraints and bounds, so I think it will give SLSQP. But I think those are all the things I need to mess with, and eventually I'll get down to it. But I also have this documentation up in this window, so I can come back here if I need it. So what am I minimizing? Well, the function I'm trying to minimize is the negative of the entropy function, which is the function I'm trying to maximize. So function is just going to be neg ent, or negative entropy, if I can paste it in the right location. So then on top of that, I need to give it some initial guesses. So minimize is going to go through and take a value. It's going to see how close the value gets to 0, and then it's going to just, start trying to solve it out from there. So I need to give it some initial probabilities. Now, I could give it some probabilities that are just maybe a uniform distribution, but let's keep this a little bit more interesting, and I will go with np dot full, which np full will just give you an array full of whatever value you give it with a certain shape. And the shape, I'll tell it to have the shape as the number of grades, which I will define that variable in a minute. And then I'll just say that maybe there's a 0.01. So my initial guess is that there's a 1% chance of a student being in each grade category. Now this of course doesn't make any sense because the number of grades is going to be 11. There are going to be 11 possible grades from 0 to 10. So then of course the grades, which I already defined the number of grades, the grades are just going to be np.arrange, and I think it's just 1r, I believe, in arrange. So np_arrange of the number of grades. And this arrange just creates an array starting at 0 and going to whatever value I give it. So in fact, let me go ahead and maybe test this out in another tab to make sure I did it correctly. Oh, wait, that's not correct. That's not what I wanted. Did I define the number of grades yet? Maybe that's it? No, okay. It seems to think it needs to give it a lot of values. Let me see. It's the same value. I don't know. Well, let's just keep going till this gives me an error. What value is it going to? It's going all the way to 100, which is weird. It's got 101 values, which is what I was testing out before. So I wonder if I maybe restart the runtime and run all. Restart and run all. Yes. Let's see what happens when I restart and run all. That might fix the runtime. If it doesn't, then I don't know what the issue is. Oh. Now it still wants the number of grades. So maybe I have to come down here and define it. Yes. Okay, so that was just an issue of me having to redefine the variable. So and this cell wasn't running because the minimize part of it was broken. So I see. I think that was the issue. But anyway, I need to give it some initial guesses, so that would just be the p, the initial probabilities, or the initial guesses for the probabilities. And then after I have this initial guesses and initial probabilities, I need to, what else should I give it? I don't want to give it a method, I'll just let it do the default. I need to give it some constraints, but I'll disregard those for a second because I need to give it some bounds. And anyway, what are these bounds going to be, if I can find it here? Yeah, here it is. So, a sequence of minimum max pairs for each element in the array. So how am I going to go about doing that? Well, I'll maybe go about saying that I want to give it a list of pairs. So obviously the bounds for the probability is going to be from 0 to 1 because it's probability represented as a decimal. And I'm actually going to put that into an array, or put it into a list with the brackets, and then multiply that list by the number of grades to create a list that is as long as the number of grades. So if I go ahead and copy this out of the thing and run it, I will get, yeah, this is exactly what I want. Just a list of, this is saying for grade 0, or for the probability of a grade being 0, that's somewhere between 0 and 1. And then for the probability of grade being 1, that's somewhere between 0 and 1, hence so forth until we've done all the grades. So now I need to define that as the bounds. And besides this, I think there's a few more things I need to give it. I need to give it some constraints, but I feel like there's one thing I'm forgetting. But I don't see it here, so let me just go ahead and get the constraints. And let's go ahead and define the constraints. So how should the constraints be defined? Well, I need to give it a constraint in the form of a dictionary or a list of constraint dictionaries. And this is going to be needed for the method we're going to use, which I think will end up being SLSQP, but I'm not going to define a method, I'm just going to let it figure out the method for itself. So this array, or this dictionary needs to have a type, and then the type is going to be equality, I believe, and then I need to give it a function and a function name. But what even are my constraints? Well, constraints are something in minimize. Constraints are functions that I'm going to give it that I need to minimize, that the functions need to work out to be 0 for a solution to be valid. So what's one constraint that I can get here just starting off with? Well, I think probably there's a really easy one. Let me go to Paint to try to flesh it out a little bit more. So I made a little note over here, sum of the probabilities. Let's think about this for a second. Logically, with any probability, the sum of all the probabilities, so the sum of pi, should be 1. With any real probability, the sum of the probability of a student of all the grades probabilities together should equal 1. Now I need to write this function in a way to where it should approach 0. So I'll go ahead and convert that to the summation of pi, or the probability of a certain grade, minus 1 is going to equal 0. So then this is the function I actually want to give it. So I'll go ahead and define maybe p sum in terms of the probability, and that's just going to be quite simply return np dot sum of p minus 1, right? Because it needs to work out to be 0 in the optimal situation. So if I go ahead and run this, I can start defining this constraints dictionary. I will give it a list, so it's going to be a list of constraints, and that list is going to be a list of dictionaries. So the first part of the dictionary needs to be type, and the type, if I go back up here, can be inequality or an inequality. This one's an equality, so I will put the colon outside, and the type is going to be equality, and then the function is going to be whatever the name of the function I want to do up here, so psum. So now, if I go ahead and run this minimize, I should get the results minimized. Let's see what happens. I got an error. What happened? Invalid syntax, because I need a colon here, not a parentheses. And sure enough, it works. So this minimize function returns a lot of different things. It returns a function value, a jack, which might be a reference to a Jacobian, or I think a Jacobian of the values. It's telling me it terminated successfully, so that's awesome. It gives some information about how many iterations it went through to get to said successful function. And then it gives me an array of values. So what are each of these values in the array? Well, this array is the actual values of p. So it's the, or of the probability. So this is saying the first value in the array would be when the grade is 0. So for when the grade is 0, there is a 9% chance of a student having a 0. It's 9% for everything. So this would, of course, be a uniform distribution. If I were to go ahead and go to part 1 and maybe copy my work from up there and come down here and maybe make this subplot again, I want to plot out the results of minimize. So let me go ahead and save the results of this as a value. I'll maybe call it probability distribution, and I will set that equal to minimize. So then I'll take probability distribution from down here, and I will say that the heights of the histogram of the distribution should be the probability distribution dot x. So it's this array of values that is returned by minimize. And let me go ahead and run this, and then so that way the variable comes up correctly in here. And so then the x values on the bar graph are going to be the bins from before, which would just be the grades from 0 to 10. So now if I go ahead and run this, I am getting results that are telling me that I should have a 9% chance or a uniform distribution of grades. So this isn't what I wanted. I want to get a normal distribution, and of course a normal distribution looks like this. So why am I here and not where I want to be? Well, that's because the only constraint I've given it is that all the probabilities have to add up to be 1. There's no, the computer has no way to know that there's an average, that there's a standard deviation, that there's any of that. So I need to go ahead and define functions for the average and standard deviation at a given value. So how am I going to go about doing that? Well, let's come over here and let's think about it. How would I find the mean normally if I were just, if I were just trying to write out the mean? Well, I would say that the mean is the summation of every data point divided by the total number of data points n. So this is how I would define the mean normally if I were just calculating it for a set of data. But how should I do it for this set of data where I want to define it in terms of the probability of I? Well, I could take the summation of the probabilities of I times, and let's think about this for a second because I just lost my train of thought, times the value of each group, right? So this would be like whether a student got a 0, a 1, or whatever, times the total number of students, all divided by n. So I guess, actually, let me just I just said that, I didn't really explain it. Let me go back and actually redo this. So what I'm saying here is that I want to break up this xi into a few different things to be in terms of the probability of I. So what I can do is I can take the number of students in each group, which is just the total number of students, times the probability of a student being in a particular group, and then multiply that by the actual grade of that group. So I'll call that GI. In this case, in my collaboratory file, I am just listing it as grades. It would be this value right here, grades. So then I can go back to Paint, and I would, of course, want to summate this for all probabilities and grades, I, and then divide that by the total number of students, because that's still on the bottom. Now, as you can see right here, n and n are going to cancel, which is just going to leave me with the probability of a student having a certain grade times the value of that grade. The summation of all that is going to give me an average. It's sort of taking a weighted average of the grades. You take the grades and you weight it per the percentage of students who have said grade. So now I can go ahead and use this mean function as a constraint. So let me program it in here. So I'll define the average in terms of the probability, and that will just return, well, what did I say? I said it's the sum, so np.sum of p times the actual grades, so that would be grades. And actually, something I didn't discuss that I meant to is that I want to give the mean a specific value. So what I'm going to do is I'm going to say that this mean, this is the mean value, minus, say, let's say the average score on the grade on the test was a 7. So minus 7, that's going to equal 0, right? Because these constraint functions need to be in terms of 0. So now I can just add in that minus 7, and that should give me a function. Now I can just, I can take this stuff over here, and I can go ahead and maybe do some copying, just make it so I don't have to retype everything. And I can go ahead and say, define the average. Oh shoot, what's going on here? Looks like I maybe copied a little bit more than I meant to. I think that's the issue. Yeah, and give it another constraint function. So now this probability distribution has two constraint functions. If I go ahead and run it, I get an error, but I think it's okay even with that error. Yeah, so this is sort of what I expected to see, right? You see, now the students don't have a uniform distribution. It's gradually increasing. Because now minimize knows, okay, the average should be 7 over here, so, but it doesn't know that a plurality of the students should get a 7. If this were a normal distribution, the average would be the most common score, right? The average would be the mean, or the mean would be the most common score. And so I need to go ahead and give it a standard deviation if I want to get a normal distribution here. So I will do something very similar with defining a function, but let's go back to Paint and talk about the standard deviation for a minute. So what is the standard deviation if I were to define it in regular terminology, right? Well, or in terms of like the individual values of points. Well, I would take xi, so any individual point or any individual value, I would subtract the mean, which is something I've already calculated here, right? And then I would square that to make sure the value is always average. And this is sort of like the difference between each individual value and the mean. Now, of course, I want to take the sum of all of these differences, but they're all positive, remember? So it's the sum of all the positive differences between each of the values. And then I'm going to take that value and divide it by the total number of points I have. So the total number of I. And then I will just take the square root of that whole thing to sort of cancel out this square root over here. And so that's how I would define the standard deviation normally. How can I define that in terms of probabilities I? Well, what I need to do is I need to take the summation, of course, but I'll leave that out for now. I want to take the difference between each grade, so each grade I, minus the average, and then I'm going to take the square root of that difference. So that's saying, at grade 1, there's a difference between grade 1 and the mean. So if the difference is 0 and the mean is 7, then you would see that this value would work out to be 49 because it would be negative 7 squared. But then I want to weight that by the number of students getting that certain grade. So I would weight that by the total number of students times the probability of a student having that particular grade I. And then I would, of course, do the same thing. That sort of is the equivalent of this summation, right? So I need to put a summation there. But then I would just take that, divide it by the total number of students, and take the square root of it. Now, something curious you'll see here is that the total number of students cancels out. So I can find the standard deviation just in terms of the probability of I times the grade, each grade. So the probability of each grade times the square difference between the probability of each grade minus the average grade. So let me go ahead and save this, and let's go ahead and put this function into Python. So I will define STD, the standard deviation in terms of probability, and let me go ahead and define the average. I'll just copy this code I did before, right? But I only need to copy this part because the average shouldn't work out to be 0. And then let me go ahead and return a certain value. So I want to return whatever I did over here. So I will return np.square root, so square root of the numpy sum of all these, whatever's in here. So so the probability of I times that square thing. So just be p times the square of the grades, so each individual grade, minus the average, or AVG, as I put up here. I don't think that'll screw anything up, the variable name. It is the same as the variable name up here, but I don't think that'll be an issue. Then, of course, I need to square that value. So now, if I go ahead and run this standard deviation function, I can go ahead and, once again, copy this and create a new condition. So this is another equation, but this time the function's name is, it's just standard deviation. So now if I go ahead and run this, I get an error, but I think it probably worked anyway. If I go ahead and plot it out, so I get something that looks a little bit right, but not really. This isn't a normal distribution, but it's closer. It's saying that, this is saying that 7% of the students get a 5, 6% of the students get a 6 on the exam, and then the other students just aren't even accounted for. So this obviously isn't correct. And the reason this ended up messing up is really because I'm not giving it reasonable values for the average and for the standard. Well, also, I said the standard deviation was 0. Okay, so that's probably my first error, is I made the standard deviation 0. So let me say the standard deviation is 1.5, and let's see if it can solve it out this time. Not quite. It says that it's still giving me those values. If I maybe give it one more attempt, it's still giving me the same values. So let me come up here and let me maybe say that, you know what, I think the standard deviation was actually closer to a 2. And this whole thing is just kind of finicky, this solver, and it doesn't always work, which is a little bit frustrating for me. So let me go ahead, and I think the reason why I'm struggling to get good results is because I'm working with too small of a sample size. I also haven't defined the number of students, which doesn't matter anyway. So let's say that instead of having 11 possible grades, there are 51 possible grades, from 0 to 50. And then let me go ahead and maybe say the average, or the class average, is, let's say the class average was a 35, and the standard deviation was a 5. I think these values might work out a little bit better. So it's still giving me that error, but maybe I'll get a more normal looking distribution. And sure enough I do, except one value is super messed up. So this is not quite a normal distribution. But if I run it again, I don't get anything better. Sometimes running it again gives it a little bit better results. Let me change it to maybe 7. Yeah, let's just say 7 is the standard deviation. Now, do I get, here is a normal looking distribution. Right? It's a little bit cut off on the edges, so maybe if I make the class average, let's say the class average was a 25 even. That'll probably mess everything up with my luck. But yeah, okay, here, this is a normal looking distribution, right? You can see that the majority, or a plurality, so the most common grade is a 25, as I defined earlier, and then gradually as you get further away, you see fewer and fewer grades further away, which is exactly what a normal distribution says I should see. So with that, going back to the prompt, I demonstrated numerically that for a given average and standard deviation, which I used as constraints in a minimize function, I could minimize the negative entropy or maximize the entropy of a discretized probability distribution, and that gave me a normal distribution. So, yeah, I hope everyone watching the face cam appreciated this video. I hope everyone watching the slouch camera appreciated the video. I don't like that camera because when I look at it, it makes me look like I am slouching, so I don't love that. But with that, I'll go ahead and end off the video here and move on to part 2A in the next video. So, thank you very much for watching, and I hope you have a wonderful day. Bye-bye.